People in hard hats working underground is what often comes to mind when thinking about how gold is mined. Yet mining the ore is just one stage in a long and complex process. Long before any gold can be extracted, significant exploration and development needs to take place, both to determine, as accurately as possible, the size of the mineral deposit, as well as how to extract and process the ore efficiently, safely, and responsibly. It can typically take between 10 and 20 years after a deposit is discovered before a gold mine is ready to produce material that can be refined into bullion. Gold mine exploration. 1 to 10 years. Gold mine exploration is challenging and complex. It requires significant time, financial resources, and expertise in many disciplines, e.g., geography, geology, chemistry, and engineering. The likelihood of a discovery leading to a mine being developed is very low. Less than 0.1% of prospected sites will lead to a productive mine, and only 10% of global gold deposits contain sufficient gold to justify further development. Once basic facts about the local geology and potentially viable deposit are established, the gold ore body can be modeled in detail and its feasibility assessed. Gold mine development, 1 to 5 years. Gold mine development is the next stage of the gold mining process. It involves the planning and construction of the mine and associated infrastructure. Mining companies must obtain appropriate permits and licenses before they can begin construction. This will generally take several years, although this varies greatly depending on location. Construction may not be confined to the mine itself. In addition to potential processing capacity, mining companies frequently construct local infrastructure and amenities to support both logistical and operational needs, as well as employee and community welfare. This development provides much long-term support for local communities, and one of the key initial ways gold supports wider socio-economic development. Gold mining operation, 10 to 30 years. The gold mining operation stage represents the productive life of a gold mine, during which ore is extracted and processed into gold. Processing gold involves transforming rock and ore into a metallic alloy of substantial purity, known as doré, typically containing between 60 to 90% gold. During its life, a number of factors, such as the price of gold or input costs, will affect which areas of an ore body are deemed profitable, economic, to mine. In times of higher prices, mining low-grade ore will become profitable as the higher price offsets the increased cost of extracting and milling greater volumes. When the price is lower or costs rise, it might only prove profitable to extract and process higher-grade ores. Mine plans are regularly reassessed as market conditions change, new technical information comes to light, and process and technological enhancements are considered. Increasingly, technological advancements are making the gold mining process smarter, cleaner, and more efficient. Mines are now designed with these technologies in mind, and electrification, digitization, and automation are becoming increasingly common elements reshaping gold mine operations and processes. Gold mine closure and decommissioning. 1 to 5 years. After a mine has ceased operations, possibly because the ore body is exhausted or the remaining deposit becomes unprofitable, uneconomic, to mine, work then focuses on its decommissioning, dismantling and rehabilitation of the land in which it was situated. Gold mine closure is a complex undertaking. A mining company will also be required to monitor the mine site long after the mine has been closed. Gold ore processing. Gold ore processing is the process of extracting gold from the rock it is found in, called ore. It is a multi-stage process that involves several steps, each designed to concentrate and purify the gold. The specific methods used can vary depending on the type of ore and the amount of gold it contains, but here is a general overview of the most common steps. Crushing and grinding. The ore is first crushed into smaller and smaller pieces. This increases the surface area of the ore, which makes it easier to extract the gold. Comminution. This step involves further reducing the size of the crushed ore particles. This is often done using ball mills, which are large rotating cylinders filled with steel balls. The grinding action of the balls breaks down the ore into even smaller particles. Concentration. Once the ore is finely ground, a variety of methods can be used to concentrate the gold. These methods rely on the fact that gold is denser than most other minerals in the ore. Common concentration methods include gravity concentration. This method uses gravity to separate the gold from the lighter waste rock. The ore is mixed with water and passed over a series of riffles or tables. The gold, being denser, settles to the bottom, while the lighter waste rock is washed away. Flotation. This method uses air bubbles to separate the gold from the waste rock. The ore is mixed with water and a chemical foaming agent. The air bubbles attach to the gold particles, causing them to float to the surface, where they can be skimmed off. Leaching. After the gold has been concentrated, it is still mixed with other metals and impurities. Leaching involves dissolving the gold in a chemical solution, such as a cyanide solution. The gold then precipitates out of the solution as a metal powder or flakes. Smelting. The gold precipitate is then dried and melted in a furnace. This process removes any remaining impurities and produces a gold bar, called a d'or bar, which is typically about 60 to 90% gold. Refining. The final step is to refine the d'or bar to pure gold. This is typically done by a process called electrolysis, which involves passing an electric current through the molten gold. The gold ions migrate to the cathode, where they are deposited as pure gold. There are many environmental hazards associated with this extraction method, largely due to the high toxicity of the cyanide compounds. For example, in 2000, the Biomare cyanide spill in northern Romania released approximately 100,000 cubic meters, 3,500,000 cu feet, of wastewater contaminated with heavy metal sludge and up to 120 long tons, 122 d, of cyanide into the Tisza River. It is important to note that gold ore processing can have environmental impacts, such as water pollution and air pollution. It is important to choose and operate processing methods that minimize these impacts. Join Reese from Gold Room at the McRae's operations in New Zealand, as he explains the gold pour process over footage of the pouring of the 10,000th gold bar.
Gold's got to be 1,064 degrees to be liquid, and so that furnace theoretically is supposed to be 1,200. You've got your niter and your borax over there to get the impurities out, but the sand and the soda ash is to keep the heat. So you suddenly don't just turn the flame off and all of a sudden it cools down, the heat is retained, and it helps you pour it, keeps it liquid while you're pouring. But once we've determined that it's ready to pour, you can see it running off the end, there's no solids, so we go, okay, we're ready to go. Set ourselves up and pour it, and obviously this thing will quite slow, because if you try to pour it too quick it's going to overrun the spell. We're very measured in our actions, so we'll go pretty slow, and I know exactly what he's doing and he knows exactly what I'm doing, so there's no surprises. That vacuum tube sample, 3 grams, will go to the lab and they'll give us a sample tomorrow, make sure we've got the purity. So we've poured the bar, and I go and turn the gas off, and then we'll bring it up to level. You ought to see me run over it with a poker just to make sure it is solid enough. So we'll pick it up, bring it over to the table, flip it out, because it goes solid real quick, I'd say 30 seconds or so, it's solid. So we aim for 95% purity, and we do that via the reagents. So we're sticking in sand, borax, soda ash and niter, and those combined will keep the heat, keep it fluid, draw out the impurities, and that's what all that black slag is coming off the top. So it's not gold, it's black, it's like obsidian. One of us will put it in the water bath, but it only needs a few minutes to cool down right down so you can touch it. And then we'll pick it out and give it a good clean. We're quite lucky, most of the bars we do are quite clean. Some of them, if they're doing low grade through the plant, they look a bit ugly and they look hard to clean, they're all quite black. So they're still 95%-ish, but they just don't look so pretty. But today we're pretty lucky. Any sharp edges, let's get rid of that. And you would have seen a few little balls of gold, so just to make sure they don't fall off in transit or get lost on the floor or whatever, just bang them down flat. So very soft. So just make a bit of a plane, put the number on it, and that's basically a recording. That is how many bars we've made since 1990. There ain't too many mines in the world that have reached 10,000, so they'll make more gold per day, but they've not been open as long as we have.